So, having looked into some sort of introduction to various services, right, introducing various services, we can now look into what is called an intelligent building, right. So, if you recollect, I might have told you sometime, I am not sure whether told you in the beginning, that building interacts with its surrounding, and the external parameters of the environment around are something like humidity, external air motion, noise, lightning, pollution, rain, sunlight, air temperature, solar radiation, all and relative humidity. Some of them we have already come across, or some may not come across, does not matter. So, this is how building interacts with its environment. Building interacts with its environment. These are the features of the environment. Some of them are man-made, some of them are, most of them are natural. This might be somewhat man-made, this might be somewhere man-made, right, but others are, others are natural. So, it must provide a safe environment against this, comfortable against external environment, both natural and man-made. That is what we have seen. Temperature, relative humidity, moisture, condensation, etc., against all of them it must be, right. And then we have seen that there you can make energy efficient building, passive and active system. Passive means which are integral part, both, all kind of services. You might have some integral part of the building which does not require any further energy, you have put it, and does not consume sufficient energy, and active system would need additional energy, like HVAC we talked about, that would need additional energy. But supposing you are designing your envelope in such a manner that your Q sensible that we talked about is minimal, fabric heat gain is reduced down, then that would be through passive means. So, that is what it is. So, we have seen this can have different like envelope, fenestration, orientation, shape, shading devices, daylighting. We will not discuss them here, but I am just telling you this is the part of the passive system, right. These are shading devices which I will not talk about. These are examples of shading devices. You can cut down in the sun, you can design such system. Active systems, I am just giving an example of passive system. Active systems are HVAC which we talked about, heating, ventilation, artificial illumination, lighting, these are somewhat active system. So, basically if you look at it, you can control some of the just let me draw it first of all. Natural variations could be something like this. Let me take you can take diurnal variation, daily variation of temperature. So, natural fluctuations or humidity, they fluctuate, they changes, and your comfort condition is somewhere, they fluctuate somewhere. Your comfort condition might be somewhere, your comfort condition might be somewhere there, something like this in between, right, and your comfort condition might be somewhere there, something like this. So, what you can do is by doing passive design, by doing proper passive design, you can bring down this perturbation, might change their phase and all that, might bring down this perturbation somewhat, so that you are close to your comfort zone somewhat. The green one is the comfort range what you desire, right, comfort zone as you desire, this might vary. So, by using passive means, can, that means even before passive, by urban design, providing plantations, you can do what is called microclimatic changes, right. Say plantations or planning it properly, air movement is controlled and so on. So, lighting is adequate in every houses, and requires mutual shading from one building to other, etc., etc. So, first is urban planning can reduce it down, urban planning stage it can reduce down somewhat, urban planning stage can give you somewhat better scenario, some perturbation, reduction is possible. Then you come to the passive. So, urban planning, then passive, but beyond that you have to use active. Beyond a limit you cannot, passive cannot bring it to this range. So, you have to use active. So, active system means energy input would be required, HVAC, artificial lighting, etc., and you would like to minimize those, that is number 1. But then you see, it is better if you keep it a constant value, or active system operates at a constant level all the time, then sometime it it will not, unless without looking at the requirement within the space. Without looking at the requirement within the space, then many a time it will be wasted. For example, supposing the room is not occupied, but air conditioner is running, because you have devised it in such a manner, like we talked of control system. Somebody comes and put on in the central AC at 8 a.m. because the office starts at 9 a.m., but all the spaces in the office is not really occupied all the time. So, in that case there will be wastage of energy. Even if you have an active system, you will bring down the within the control, but there will be wastage of energy and possibly overdo the whole thing. Now, if you put control, that we have said, we talked about, then obviously it can make it within that operating differential very easily. So, therefore, control means, when we talked of control, we said that we need a feedback, and when you have feedback, so this diagram shows the same thing what I talked about, urban design, and then like passive, and then if you want within that narrow band of comfort zone, you have to use active system. And when your all control system are controlled through computer, then it gives, it becomes an intelligent building. In an intelligent building, the control systems will be there in many features, right. Control system will be there in many features, and control system means you will have a feedback. So, you will have sensors. These sensors will sense the condition within the control environment, send signal, and when all the full number of them are controlled together with a computer, that becomes an intelligent system. So, definition is something like this: intelligent building is used to describe a building capable of achieving optimum life cycle cost of occupancy and increased organizational productivity through its inherent design and management. Well, this is very broad definition, because overall life cycle cost it will improve, it will optimize the life cycle cost and of occupancy and increased organizational productivity also, because it will maintain the ideal condition all the time as required, right. So, essentially one which provides productive and cost effective environment through optimization of its basic 4 elements: structure, system, services and management, and interrelationship between them. So, this is what the definition of intelligent building is. So, that this building intelligence is essentially based on something like this. So, this is what is we will have office automation system, telecommunication, and all inclusive, right. All inclusive. Let me see, I will come back to this later on a little bit. First diagram again. Temperature, humidity, pressure, time, other data. So, there is a, for building active systems, temperature, data, these are all collected, and this is an integral part, this is an integral part of an intelligent building. So, this will monitor and control, this will monitor all the data, right. So, building automation system will monitor all the data, actually temperature, humidity, pressure, time, or whatever you desire, and then that builds in building a intelligent system. So, therefore, if I look at it, this is the data acquisition, then telecommunication and system, office automation system, and other systems, all systems are automated, and that results in intelligence building. So, that is what is it. automatic controls are used where variables condition must be controlled. So, you have automatic, that is what I think. Control system should be integrated with system design, both have to work in harmony after final installation. Majority of control are for HVAC system, majority of the control, but then like many places nowadays is very easy thing, you enter and you find lights becomes on. So, essentially similarly the HVAC system temperature is monitored. Now, if there are a lot of people, obviously the heat to be removed is more. If there are no people, without doing much you can monitor possibly, but also if it is equipped with another system where it looks into the presence of human being, the signal goes in if there is a person enters or person goes out, then you can go to any extent, actually you can go to any extent, right. So, objective of control system are safe plant operation, protection to the building and system component completely, maintenance of desired condition and economy of operation. Now, you see in earthquake structural system also you have active control system against earthquake. There are various kind of like it is a domain of structural engineering, research domain of structural engineering, and there are various kind of active control systems, where during the earthquake the building react in a given manner to counteract the effect of earthquake onto the structural system. So, all put together the complete intelligent building system will have everything possibly. But then in services, of course, this has been used earlier than fire, for example, automatic sprinkler system. Automatic sprinkler system is nothing but an intelligent system the moment it sees. So, this has been there for quite some time, and that is why the safe operation, protection of the building and system components, maintenance of desired condition and economy finally it results in, because you will use it only and only when it is required. Limiting the plant operation period, therefore, it does limiting the plant operation period, economical control of the space condition, it will not go too far beyond, right, and efficient plant operation to match the load, monitor the system performance. For example, if I had you remember we talked of in case of water supply system or general system we need storages, because there is a imbalance between demand and supply. But supposing I can control my supply in such a manner that I match exactly with the demand, then I wouldn't need storage. So, if the better control on my supply would actually minimize the storage cost and so on. So, that is the idea. So, control systems will have sensing devices, it measures to measure the values of the design variable which we talked about earlier. Controller, they compare the measured variable with the desired set point, that we have already talked, and to send it to control device. Signal control devices regulates the input to the controller, for example, proportional valve opening, etc., that is what it does, the control system does. So, disturbances, this we talked about earlier, and this is where it is, So, this is when you do it for almost all variable through a single system, automated system, that gives you an intelligent building actually. Well, nature of heating and air conditioning system is such that for majority of the period of operation, plant and system capacity will exceed demand. Right, if you put it on for all the time, and the order of this excess varies with time. How much what is required and how much you are actually providing. Usually, you provide more. Steady state condition may be assumed, which obviously never occurs. That is the assumption we make. Actually, there is a variable state for the load required, variable state, time variant. If the plant were to be uncontrolled, the condition of the occupied space would be outside the desired range, and consequences of which some means of control is fundamental requirement. So, that is what we have seen earlier also, and various types of controls are analog output, digital control, digital input and digital output. Now, essentially these are the system that is available, but today everything is now digital system. And 2-point control I have already talked about, proportional control, integral control I have mentioned, derivative control, adaptive control, floating control and step control, these are the other types. So, we have discussed about some of the features of these ones earlier, and there are some more available. And methods is pneumatic, not common. Today it is all direct digital control, electric or electronic, and today it is all direct digital control. So, that is what it is, DDC, that is what it is, direct digital control. So, that is what they have, and they will have sensor, controllers, system integration units and man machine interface, right, which could be simply the like monitors and things like that. So, that is man machine interface. So, that is what it is, So, man machine interface, that shows it. Then system integration units, the direct digital controls, there are sensors from where like there may be some space where you have from where you direct digital controls come, DDC, they are system integration units, and that finally it goes to man machine interface. So, this is what the schematically for an intelligent building, this is what it looks, the controlling system looks schematically looks like this. Okay. Sensors could be for temperature, humidity, flow, lux level, pressure, liquid sensor, height of the tank, right. Various other kind of transducer and actuators. The actuators are required if you want to counter something. For example, in earthquake they use actuators, or somewhere vibration which would induce vibration, things like that. There could be various kind of things. Each DDC controller identified by number of points, connection with number of sensors. So, every direct digital control system will have number of sensors, and this is identified by number of sensors. It is connected to say in modules of 4, 8, 16, 32, 64, 128, etc., in terms of this. So, more number of DDCs means each DDC connected to lesser number of points. If you have more DDCs, less number of sensors will be connected to it. Cost goes higher if more controllers are there. So, if DDC controllers are there, so you have to actually optimize this, or rather you have to see that it is optimized, because it is the electronics or the hardware engineers will do this kind of job. But we have the knowledge that this is to be optimized. More DDCs, more cost. Less DDCs, less DDCs, the system optimization, system performance might be affected, and so on. And this is what typically it might look into some cases, man machine interfaces, DDC controllers, this might look into some places. There is actual photograph of a building, and basic single zone control, for example, in air handler, example in an air handler. So, this is our blower, filter, etc., AC. Now, the control would be finally the amount of flow that is to be controlled. So, you will have DDC, of course, it is not shown here. So, for example, the quantity of flow finally has to be, so this is the direct active control, direct active control. They would control the amount of flow, and DDCs actually send the signal and actual controller will control, right. So, a detail something like this, the controllers are here, this is your air conditioning system, the duct, and the controller sends a signal and the flow would be controlled. So, this gives some schematic of some schematic with the air conditioning system how controller can work. Okay. These are two buildings, one with a manual control, this is with a automatic control. I think this is somewhere in Gurgaon. One of my students did a project and we are trying to compare how do they perform. Two buildings almost similar, one with manual control, another with automatic control with building automation system. Somebody has to monitor them. So, there are of course still there are some, as I said, this was supposed to be partially intelligent, the India Habitat Center, the computer maintenance CMC building in Mumbai and all that. So, the report of their performance is not really known, but somewhere some has to look into what is the cost saving and of course, the performance related to the people, what do they feel about it, because their comfort condition if it is maintained adequately or not. CBRI has got a building constructed, instrumented with various kind of system. Building means it's just about a 2-story height building, small building, and possibly there are some experiments they will be doing. So, not much data is available at the moment on Indian side of how do they perform, but they are surely this is the system one calculation. So, this is the ultimate of services system with total control system, right. So, that is it, that is about intelligent building.